Good day, everyone. Today we will learn how to solve kinematics problem in one dimension. Let's get into it. Physics tutorial with Circus. Kinematics is, under mechanics, a branch of physics that deals with the study of motion. Its counterpart is kinetics, which describes motion in terms of the forces that moves objects. Kinematics describes motion without talking about the involved forces. It talks about distance traveled by the object, displacement, speed, velocity, acceleration, and the time of motion. Kinematics is divided into two types of motion: rectilinear motion, which occurs in one dimension, and projectile motion, which can occur in two or three dimensions. There are two types of motion under rectilinear motion: a motion where objects move with constant speed or velocity. We can call this as CVM, or constant velocity motion. The second type is a uniformly accelerated motion, or commonly called as UAM. The classification of motion as either constant velocity motion, CVM, or uniformly accelerated motion, UM, is crucial for solving rectilinear motion problems. This is how we view a constant velocity or average velocity motion. For a constant velocity motion, the object has the same speed for its entire motion. For average velocity motion, the object changes speed many times, but only the average of all those velocities are considered by the problem. In this example, the car changes speed from 5 meters per second to 3 meters per second, then to 7 meters per second and 5 meters per second, but only average of all those velocities is considered in the problem. The average velocity for this motion is 5 meters per second. These are the equations for constant velocity motion. Take note that we will only use these equations if the problem describes a constant velocity or average velocity motion. This is how we view an accelerated motion. Acceleration is the rate of change of speed. Acceleration happens every time an object changes speed, either by speeding up or slowing down. These are the equations to refer if the problem situation describes an accelerated motion. VI is initial velocity, VF is final velocity, is for acceleration, D for distance, and T for the time of motion. Remember not to use these equations if the situation describes a constant velocity or average velocity motion. If you're good with memorization, you can memorize these equations for your exams. We will get back to these equations on our examples. This is my suggested strategy in solving kinematics problem in one dimension. Identify what type of motion is the given problem. Is it a motion with constant velocity or uniformly accelerated motion? If the motion describes a constant or average velocity, use the CVM equations. If the motion is an accelerated motion, then use the UM equations. Write the given quantities. It is very helpful to write the given quantities so that you don't have to read again or look for the values from the question every now and then. It saves you time and effort. Look for determining words from the problem. The word rest, at rest, and stop means the velocity is 0. Identify the quantity asked by the problem. Identify what formula to use to solve for what is asked based from the given and asked quantities. Once you know which formula to use, the process involves straightforward substitution. By mastering these steps, kinematics problems will become significantly easier. Let's work on our first example. in going to school from your house. You traveled a total distance of 9,500 meters in a span of 30 minutes. What is your average speed for this motion? The first and very important step is to classify what type of motion described by the problem. In this case, it describes an average velocity motion. So we will refer to the CVM equations. We write the given. Distance is 9,500 meters. Time is 30 minutes, which is equivalent to 1,800 seconds. The problem is asking for the velocity. Pause the video and try to identify which among equations, 1a, 1b, or 1c is to use to solve for velocity. From the given quantities and asked quantity, the equation to use is equation 1a. After knowing what equation to use, we substitute the given quantities to the equation. Easy peasy.
Nice.
Example number 2. A cyclist starts with an initial velocity of 3.0 meters per second, accelerates at 1.5 meters per square second, and travels a distance of 20.0 meters. Calculate the final velocity. What type of motion is described by this problem? CVM or UEM? This is a UEM problem, so we will refer to the UEM equations. We write the given. Acceleration is 1.5 meter per second squared. Distance is 20.0 meters. Initial velocity is 3.0 meters per second. We are asked for the final velocity of the cyclist, VF. Which among the equations on the left contain the given and asked quantities? Which equation has acceleration, initial velocity, displacement, and final velocity? It's equation 4, and if we look on the variations of equation 4, we will use equation 4c since we are to compute for the final velocity. Now that we know what equation to use, we can just simply plug in the given quantities to the formula and compute. The final velocity of the cyclist is 8.3 meters per second.
Oh my God! Wow!
Here are more examples. For each example, try to pause the video and solve for the answer.